Okay? All right, so now we're going to go the other way. Okay? So we had this position graph. Now we're going to look at that if it's a velocity graph. We're going to see if we can figure out what our position time graph is going to look like.
But there's a problem, Mr. Auwerda. I don't know where you started.
You don't know where we started, okay? And so either the problem's going to have to say where you started, or it's going to be a general thing. So we're going to go ahead and say start at 0 meters. So right at the reference point.
And if I remember right, we're moving away the whole time, right? So we're just going to have to
because
go
the velocity
upwards.
is positive.
So it's okay to
the whole
put
time.
0 down where you just indicated.
0. And this is
Okay,
position.
so position and time on the bottom.
And time.
Okay, well, I'm speeding up so for the first section of the graph. So my first section from here, I'm speeding up. I start at 0 and I end up at 2 meters per second. So I'm not going to have just a straight line. I'm going to have like a curved line.
Right.
Now,
Now,
I
do you
figure
know?
out how far I went.
Okay.
Okay, so remembering from the activity, how far my displacement was the area.
Okay. Now that's a triangle. Does that make area hard?
Oh no, area of a triangle, 1/2 base times height. Okay, so my base looks like it's 3, and my height looks like it is 2. Oh, and I should have put some units in here. 3 meters per, or 3 seconds for my base, height 2 meters per second. So when I'm looking at my units, seconds cancel, and I'm going to end up with 3 meters.
All right. So you know in this first section, your displacement was 3 meters.
Right.
Okay. So because I told you where you started, you know also
Okay.
where you ended. Okay.
So I'm going to end at 3 meters away from the detector.
All right. Now this next section, okay, this one I can do because it's nice and flat.
Oh yeah.
Okay. Area again, but this is a rectangle, so it's just base times height.
Mhm.
And again, I want just this section of base. So from 3 to 6 seconds is 3 seconds. So 3 seconds times its height, 2 meters per second. 2 meters per second equals 6 meters. Okay, so in this next 3 seconds, we traveled 6 meters.
Okay, and I also do it at a constant rate. So when we
Right,
do that, it's
this
going to
is a
look a little bit
constant
different
velocity,
than our
so
first one.
This one is curvy. This one is constant. Okay, so I'm going to put up here constant,
And,
and
that
over
one's gonna be
here,
speeding up.
speed up. Okay, and our last section.
Okay, our last section we're going to slow down so we can fill that in.
Okay, remember this is a negative slope. Doesn't mean we're moving the other direction. It
Right.
just means we're slowing down.
We're slowing down instead. So we're still moving away, but we are slowing down. So triangle again, 1/2 base times height. So equals 1/2. The base is 2 seconds, and the height is 2 meters. So that looks like 2 meters. Oops, meters per second down here.
All right. So we had a displacement of 2 meters, which gives us a total displacement. We moved 3 meters away, then we moved 6 more meters, then we moved 2 meters, which is a total of
That looks like 11 meters
11
total.
meters.
So our graph needs to go clear up to 11 meters. There
All
we
right.
go.
Well, I've only got 1, 2, 3, 4, 5, 6, 7, 8
So it looks like we're going to have to
spaces.
scale it by 2s.
So let's go by 2s. Yep. 2, 4, 6, 8, 10, 12. And down here I can go by 1. So 1, 2, 3, 4, 5, 6, 7, 8. All right.
Okay, so the first one we need to move 3 meters in 3 seconds. So maybe let's
3
put,
seconds and 3 meters is right here.
yeah, so that's where I need to end up.
But this says speed up.
Okay, so if I remember right, the speed up looks like, I'll switch to, the speed up looks like I'm kind of going slow, and then my slope is increasing, kind of like that.
Okay, and I like that because if we look at this section, we can see it's kind of flat,
Mm-hmm.
which means it's slow. And as we move along, it gets steeper
Yeah,
and steeper,
the slope
so its
increased.
slope increases. Now the next section, we need to go 6 meters,
Okay, but it's
which-
not just go to 6, it means go
6 more
6
meters.
more
So
meters,
from
so
3 plus 6 is
9. So I need to end up at
I
9.
need to end up here, and I'll switch to blue. Okay, so I need to end up at 9, but this one is constant, so
Right,
I can
so I
just
can just connect
connect
the
the
dots.
dots.
Cool.
And then
Okay.
our last one,
Final one, we need to go 2 more meters.
2 more meters, so we end up at 11 in 2 seconds.
But we were slowing down, so we kind of need to
start steep
even it out.
and even out.
Yeah, cool.
Okay, so we have a curve for each one where we have a changing speed and a straight slope where it's a constant speed.
That wasn't too bad.
No, that's pretty easy. Okay, now, some things we should keep in mind about these graphs. Okay, when you have a position time and you're going to a velocity time graph, the thing that you have to pay the most attention to is slope. Slope tells, well, the magnitude or the absolute value of the slope tells speed. So magnitude is speed. Okay? The sign, what is the sign of the
The
slope?
sign of the slope is going to tell me if it's toward or away.
Right, so that gives us the direction. So remember, velocity is a vector. We need 2 things.
Right.
We've got to have both speed and direction. So the magnitude of the slope, the steeper it is, the faster it's going. The direction it's sloping, slopes up is positive, it moves away, slopes down, it's negative, it's moving towards. Okay? Velocity time to position time graph. This one is a little bit trickier. The area gives you displacement. Okay? Now displacement is final position minus initial position. Does not tell you where you start and where you end, it just tells you how far you went. Okay, so when you're doing this, you have to be given the starting point. Okay, otherwise you can't. There's not enough information. Okay, and we didn't see it in this example, but what if we had a velocity graph that went like this?
Well, and then it's going to be a little bit trickier because anytime I've got a velocity graph, I always like to put, okay, up here is away and down here is toward.
Okay.
So then right here I'm going to be switching between going away and toward. So here I'm going away at a constant rate, then I'm going to start slowing down until I stop for this little instant, and then I'm going to start speeding up in the opposite direction toward, and then I'll be moving at a constant rate toward.
Right. All right, and if I want to know how far I went here, this is actually, this area would give me a negative displacement. Because when we calculate area, we're not actually calculating an area, a surface area, we're calculating a displacement because it's meters per second times seconds. And since our meters per second are negative, our height here would be negative. So when we take base times height, we're going to have still our seconds times negative meters per second, which will give us negative meters, which just means we're moving
In the opposite direction, right?
direction, back towards where we started. Okay? So slope and area are the 2 things you need to go back and forth between position time graph and velocity time
But we
graph.
shouldn't need to memorize this, right? We should be able to reason it out because a position time to a velocity time, we're looking at the slope. So if we remember, position time is meters in second and slope is rise over run, that will get me the velocities in meters per second.
Exactly.
But now if I'm looking at the velocity time, velocity is in meters per second, and this is seconds. If I multiply them, which multiplying gives you an area, then I get my meters. So I can look at the units and reason out what I need to do.
From the units. All right.